Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will be looking at some important aspects that we should take heed of when doing electricity calculations. Now, if I have this example here, and I have all these as ammeters, all of them are ammeters, then how will we know how much current is flowing in the circuit? So let's assume that the current going through this ammeter is 3 amperes. Then the question arises, what happens to the current when it comes to this point here? Does the current split equally, or how does it work? So 3 amperes of current come to this point. Then some of the current will go in the top branch, some of the current will go through the bottom branch. So how much current goes through? It will only be equal if the resistance at the top is equal to the resistance in the bottom. So if the resistance is equal, then the current will split equally. But assume I tell you that the resistance on the top is smaller than the resistance at the bottom. Then the current going through the top will be greater. So we can assume that if 2 amperes of current goes through the top, then how much current will go through the bottom? And because 3 amperes of current came to this branch and 2 amperes went on the top, we can say 1 ampere of current will go through the bottom. So if the resistance is smaller here, so we have a smaller resistance on the top, then we're going to have a greater current. And as we see that the current comes to this point here, 2 amperes and a 1 ampere will come here, then the current going through this resistor and this ampere will again be 3 amperes. So from here we can have a specific rule that we can say, if you look at current in series, when we look at current in series, the current in series is at this point and at this point. We can say that current in series is equal, because in our case we can say they're both equal to 3 amperes. Then what we can also say, that if you look at current in parallel, the current in parallel is such that the current in parallel is such that the 2 amperes and the 1 ampere will give us 3 ampere. Current in parallel is added to give total current. Now this is very important, especially in circuit calculations, where they ask you to calculate current going through branches, and if they ask you to what is the current through the main branch, etc. So what we must know is that current in series is equal and is usually equal to the total current, and current in parallel is usually added to give us the total current. Current in series is equal, we see that it is 3 amperes and 3 amperes. Current in parallel is added, 2 plus 1 gives us 3. So that's the first aspect to remember. If you look at the other example that we have here, we see that we got voltmeters. When we look at potential difference, an important aspect of potential difference, we can see that V1 will be V total in this case. V1 is V total, because the V1 is across the cells or the batteries, and they are what gives the potential difference to the whole circuit. So what the rule is, voltage or potential difference in parallel is equal. It's the opposite of current. In current we saw that current um, in series is equal. Here we see voltage in parallel is equal. So if you look at this diagram here, we can see that V4 will be equal to V3 plus V5 together. The total resistance of V3 and V5 will be equals to the potential difference of V4 is equal to the potential difference of V3 and V5 combined. So even if I had to put a voltmeter here, for example, and I can call that maybe V6, then we can say that V4 will always be equal to V6, and that is the rule relating to voltage in parallel. And the other rule that we must remember is that voltage or potential difference in series is added. Voltage in series will be added. Now, if you look at our example, we can say that voltage in series is added. So in our example, we can say that V total will be equal to V2 plus V6. Or it could also have been V total is equals to V2 plus V4. So here we see that your total voltage, if for example we take numbers and this was 12 volts and this was 4 volts, then what we can say is that V4 will have to be 8 volts, because 8 plus 4 will give us 12, and V6 will have to be 8 volts. And if for example V3 was 3 volts, then this one will have to be 5 volts in order to give us 8 volts. So these are very two important aspects to remember. The first one is that current in series is equal, where we see that when we have the main branch, all the current goes through the main branch, whether it's on the left hand side here or on the right hand side here. And current in parallel is added, where we can see that if 2 amperes of current go through the one branch, then 1 ampere will go through the other branch. And the other example that we've looked at here, we can see that voltage or potential difference in parallel is equal. So if we have V4 equal to 8 volts, then V6 will also be equal to 8 volts. And we know that voltage in series must be added. So we can say that V2 is in series with the whole parallel part. So we can say V2 is in series with V4, and V2 plus V4 will give us V total. So if V2 is 4 volts, then V4 will be 8 volts in order to give us the total of 12 volts. So these are very two important aspects that we must remember when doing electricity calculations. Thanks. We will stop there. Thank you very much for watching.